So dimension analysis. Okay. Dimension analysis. Okay. So here what we are writing is for M, we write capital. For mass, we write capital. For length, we write capital. For time, we write capital. For temperature, we write K. Okay, but we are not using that. Okay. Now, so if it is like, speed equal to what? Distance by time. So we write here speed equal to L by T. That is equal to L T to the power of minus 1. If it is area, we write what? X L square, or area is equal to L square. Implies area is equal to capital L square. If it is volume, X cube, we write. So it is written as V is equal to L cube. Here. Now that way we write. Now, if you have force, F is equal to what? Ma. So first we'll do acceleration. Acceleration is equal to what? Change in velocity by time. V minus U by. So that is equal to what? L T to the power of minus 1 by T. That is equal to what? L T to the power of minus 2. Now, next is what? F is equal to Ma. So F is equal to what? Ma. Ma is capital M. L T to the power of minus 2.
Sir, in acceleration, V minus U by T is equal to LT raised to negative 1 by T. We should add the T.
No, see, when we bring this T in the numerator, plus
It's
1 will
negative.
become minus 1, right?
Ah.
See, this will become L T to the power of minus 1, T to the power of minus 1. This is
Minus 1.
at the
Ah,
top.
okay.
So
Okay,
work done is equal to what? Work done is equal to force into displacement. So W equal to what? ML T to the power of minus 2 into L. So W equal to what? M L square T to the power of minus 2. This is work done. Next one is what? Next one, we have whether it is potential energy, kinetic energy, and all. Okay, now we will write pressure. Pressure is equal to what? Force per unit area. So pressure P is equal to what? Force is ml square, ml T to the power of minus 2 by L square. So when you bring this in the numerator, it will become M L power minus 1 T to the power of minus 2. Now, next one is what? Energy is equal to mgh. Potential energy is equal to mgh. So potential energy is equal to M L T to the power of minus 2 into L. So that will become ml square T to the power of minus 2. Is it clear? So that way we can write for kinetic energy. Same formula. See, work done and potential energy, kinetic energy, all will be having same dimensional formula. Half mv square.
So potential energy, can you repeat?
See, potential energy is mgh, right? See, the dimensional formula of work done, dimensional formula of potential energy and kinetic energy, all the energies is same. Any type of energy. Any type of energy.
Okay.
Yeah. Now, so it is equal to how much? M half is not considered. M L T to the power of minus 1 whole square. So that will become M L square T to the power of minus 1. Okay. So like that, we have stress by strain. That is Young's modulus equal to stress by strain. There is one more formula. Okay. Stress is what? Stress is force per unit area, and strain is right here. Force per unit area. Strain is change in length by original length. So that will cancel. So L by L. That will become L by L. So force is what? So we can write F into L divided by A into delta L. So this will become ML T to the power of minus 2 into L divided by area is L square into L. This and this will go away. So M L power minus 1 T to the power of minus 2. ML, yeah, L and L go away. ML power minus 1, yeah, and T to the power of minus 1. Okay, is it clear?
Yes, sir.
Now, so checking the dimensional consistency of equations. Okay. So we are doing applications now. Okay. Now here we have to check s is equal to, there is a formula here. S is equal to ut plus half k t square. So what is that? LHS is equal to what? LHS equal to S is equal to L. S means distance. Now your RHS equal to what? ut plus half k t square. Ut plus half k t square. So what it will be now? U is equal to what? Initial velocity. L t to the power of -1 and t is again t. Plus half is not having anything. No significance. The acceleration is L t to the power of -2 and then t square. So what will happen? L into t to the power of -1 plus 1. And here L t to the power of -2 plus 2. So here what will happen? Equal to L t to the power of 0 plus L t to the power of 0. So t to the power of 0 value is 1. So L plus L will become 2L. So again 2 is not having any significance. So LHS equal to RHS. Is it clear? Is it clear? LHS equal to RHS.
Yes,
Understood?
sir.
The first one. Second one is deducing relation among the physical quantities. Second one is deducing relation among physical quantities. Okay, so deducing result among any physical quantities. So what is the formula now? So here we have here the time period of a simple pendulum depends upon length. It depends upon length. It depends upon the gravity. It depends upon the mass. We will write like this. Okay, he has given the proportionality. So what do we write here? T is equal to what? K into L power x, G power y, M power z. So T is equal to what? T is equal to K into L power x, L t to the power of -2 into y, and M power z. So here what is that? T is equal to K into L power x, L power y, t to the power of -2y, M power z. So t to the power of 1 is equal to K into L power x. This same, if this is also add the powers, t power -2y, okay, and M power z. So equating the powers on both sides, equating powers on both sides. So t to the power of 1 is -2y is equal to 1. So y is equal to -1. So x plus y is equal to 0. So x is equal to +1/2. Z equal to 0. So when we substitute this value, t is equal to k into, so we can write here L power 1/2, L power 1/2 and G power -1/2. So if you know k value, that is we can write 2 pi under root of L value. This is the time period of a simple pendulum formula. This is the, in practical also we did this. Remember? Time period of a simple pendulum. The next one is third one. Converting from one system to another system. Suppose here we have 1 Newton equal to what? 1 kg meter square per second square. Equal to how much gram meter centimeter square per second square. Gram centimeter square per second square. So here how much it is? 1 kg is equal to how many grams? Kg meter square second power -2. That is 10 to the power of 3 grams. 1 meter is equal to 100 centimeters. So 100 square. So that we can write gram centimeter square second power -2. 10 to the power of 3, 10 to the power of 4. gram centimeter square second power minus. So bases are same, add the powers. So this whole thing can be written as dyne. So 1 Newton is equal to 10 to the power of 7 dynes. Clear? Is it clear? Yes?
Sir.
Yes, sir.
Next is 1 joule. 1 joule is equal to 1 kg meter square per second square, which is equal to how many? Gram centimeter square second power minus. That is equal to how much? 10 to the power of 3, 10 square, whole square, gram centimeter square second power minus. Okay, so that will become how much? 10 to the power of equal to 10 to the power of 7. What is that? Erg. So 1 joule equal to 10 to the power of 7 erg. Clear? So this is the way of converting. Got it?
Yes, sir.
So this is a way of converting from one system to another system. And there are some disadvantages or limitations of dimension analysis. Number one, for constants, we cannot determine the value. Okay. Constants means like 2 pi under root L by G. There it was K. Unless and until you know the theory, you cannot write 2 pi there. That is the first part. Second part is what? Second thing is, like suppose kinetic energy, potential energy are having the same dimensional formula. And work done is also having the same dimensional formula. But the physical meaning is different. Potential energy is not same as kinetic energy. Kinetic energy means energy possessed by the body when it is in motion. Potential energy means when the body is at a particular height. Okay. When the body is at a particular height, then that is potential energy. When it is in motion, it is kinetic energy. But the meaning is, physical meaning is different. But even though the dimensional formula is same, but the physical meaning is different. So this is also one of the drawback of dimensional analysis. Okay. So this completes your lesson. So tomorrow, I will tell you about the next class. Okay, I will message you. Okay.
Okay, sir.
So it's not tomorrow.
I will try to take, but I want some more students to be in the class. Not just like one or two. It's very, the more the students encouraging, for me also it will be more encouraging, I can take